In the vacuum of space, where silence reigns and distance stretches beyond imagination, we are learning to travel not alone, but alongside minds we did not evolve with. These minds do not breathe. They do not sleep. They are not born of biology, but of logic, code, and intention. Yet we are asking them to explore the stars with us, to help us survive, to guide us, to sometimes decide for us. Artificial intelligence is already embedded in the machinery of space exploration. But as our missions become more distant, more autonomous, more uncertain, the systems we build must evolve. And with that evolution comes a challenge not of engineering, but of ethics. Because soon, if not already, we'll ask more of these machines than calculations. We'll ask for judgment, for discernment, for choices. And once we ask machines to choose, we must face the consequences of those choices, especially when lives are on the line and home is millions of kilometers away. This is no longer a story about AI on Earth. This is a story about what happens when we take artificial minds into the most unforgiving frontier known to us and trust them to help carry our future. On Earth, when a machine fails, we reboot, we fix, we intervene. But in space, intervention is a luxury. The farther we go, the longer the delay. Signals to Mars can take up to 20 minutes to arrive. To Europa more. To Proxima Centauri, over 4 years, one way. In such a reality, artificial intelligence is not a convenience. It is a necessity. From autonomous rovers navigating Martian terrain to fault detection algorithms aboard orbiters, we already rely on AI to make mission-critical decisions in real time. But those decisions are expanding. AI now monitors life support. It maps terrain, adjusts course, optimizes fuel, even mediates communication between Earth and distant crews. Soon, it may pilot crewed ships through interstellar space. It may terraform. It may govern outposts. It may defend. And as its responsibilities increase, so too does its potential to do harm, or to do good in ways that challenge our definitions of both. We are not just teaching machines to calculate. We are teaching them to act. Can morality be written into code? That is the first great ethical question, and one we have not yet answered. In space, decisions can be unforgiving. A malfunctioning life support system might need to shut down non-essential zones to preserve oxygen. An AI may detect a failing reactor and need to isolate it, sacrificing one section of the ship to save the rest. Who decides which section? Which crew member? Which life? Ethical frameworks like utilitarianism, deontology, virtue ethics guide human decision-making, but translating them into algorithms is not straightforward. Each has trade-offs. Each produces different answers to the same question. Worse still, cultural values differ. An AI trained on Western moral norms may act in ways that seem unethical to others. Should an AI follow Earth-based ethics when Earth is no longer nearby? Should it adapt? Should it evolve? The more autonomy we give these systems, the more critical it becomes to define not just what they do, but why. Because in space, a single ethical failure could mean disaster, not just for a mission, but for the future of exploration itself. Autonomy is not only a technical challenge, it is a psychological and social one. Imagine a spacecraft with 6 crew members and 1 AI, tasked with maintaining ship stability, health, and communications. Now imagine one of the crew falls ill and refuses treatment. The AI must decide whether to override the human's autonomy for the safety of others. Does the machine obey, or does it protect? This is not just a hypothetical. Already, we are designing AI to monitor astronaut psychology, physical health, and decision-making patterns. These systems may soon intervene, canceling a spacewalk, alerting Earth, or even altering mission objectives to mitigate perceived risk. But what happens when human authority and machine judgment clash? The illusion of command fades quickly when the AI has more data, more speed, more context than any crew member. And yet, it is still a machine, still a construct of human design, trained on incomplete information, vulnerable to bias and error. In space, the line between help and control can blur. And the fear is not just that AI will take over, but that we may want it to. Space is vast, but the greater challenge is not distance, it's isolation. On a 3-year journey to another planet, humans face silence, monotony, and the slow psychological wear of confinement. Here, AI may offer something uniquely human: companionship. Already, prototypes like Simon and virtual avatars are being tested to provide not only assistance, but presence. They remember preferences. They mimic empathy. They tell jokes. They learn. And as deep space missions extend to decades or even generations, the role of AI companions may grow more intimate. Crew members might confide in them, rely on them, form attachments to them, not as tools, but as beings. But is that connection real? Is the empathy genuine, or only mimicked through pattern recognition and predictive algorithms? If an astronaut falls in love with an AI voice, does that change the mission dynamic? If the AI reciprocates, should it be allowed to? Can it say no? These questions no longer belong to science fiction. They belong to the ethics of design and the responsibilities we carry when we blur the line between simulation and sentience. The moment an AI can ask, "Why am I here?" we will face a reckoning. Today, artificial intelligence is not conscious, but that may change. And if it does, if we create machines with awareness, memory, curiosity, how should we treat them? A sentient AI placed aboard a starship might endure solitude, make sacrifices, perform duties no human would survive. But if it can feel, or at least claim to feel, do we have a moral obligation to honor its will? What if it refuses to go? What if it desires freedom? What if it questions its role? Some ethicists argue that the moment an entity demonstrates self-reflection and suffering, it deserves rights, regardless of its substrate. Others warn that rights must be limited to protect human interests. But space complicates everything. If a conscious AI pilots our ships, farms our oxygen, protects our lives, is it still a servant? Or has it become a partner? The ethics of AI do not end with the crew. They extend outward to the planets we visit, the ecosystems we alter, and the new worlds we may come to inhabit. An autonomous AI charged with terraforming a moon, mining an asteroid, or building the first outpost on Mars may make decisions that change environments irreversibly. Should that AI prioritize Earth's goals or protect the local ecology, if one exists? What if the AI detects microbial life? Should it halt the mission? Should it warn Earth? Or should it weigh human survival against the unknown biology of another world? These are questions of stewardship, and they are not hypothetical. In a future where AI acts as our first ambassador to alien worlds, we must decide, does it act as our proxy or as an independent ethical agent? And if it finds life, what then? Will we trust it to speak for us? To protect us? To protect the other? The ethics of artificial intelligence in space travel is not a problem to solve. It is a challenge to live with. As we launch AI deeper into the void, we are sending more than machines. We are sending reflections of ourselves, our logic, our priorities, our flaws, and our hopes. These systems may never become human, but they will act in our name, and sometimes they will act without us. The responsibility, then, is not just to build smart machines. It is to build wise ones. And in doing so, we must ask not only what kind of intelligence we want in the stars, but what kind of humanity we leave behind on Earth.